from the current slide. And the two major announcements, you've heard them ad nauseum probably, but 1 week from tomorrow, I believe that's right, yeah, tomorrow's the 5th, yeah, 1 week from tomorrow, on the Birmingham West Campus, the Lawson State College Transfer Fair Day will be held, and this will be from 9:30 to 11:30 on the academic in the academic building, that's B Hall, and that's that's that long building all up and down that building in the hallway there. Have tables set up for the various universities and colleges to come and help try to recruit you, okay, or help you transfer to their institutions. Then a week from the day after tomorrow, Thursday, February 15th, there'll be this campus in this building, and it'll be, they say in the campus cafeteria. I'm thinking near the campus cafeteria, probably in the faculty staff dining room, which is right next door to it. If they need more tables or more room, they'll probably be out in the hall outside of that. They could be in the cafeteria too, but with the end of breakfast and beginning of lunch right around these times, I would think that's going to be awfully inconvenient. Okay. But anyway, bunches of universities and colleges have been invited. I bet you most of them will be showing up. They're hungry for good students. And then, this is the one more specifically for you guys who hopefully are mostly pre-engineering, though not all of you are. But if you know others that are, especially mechanical, electrical, and material engineering, this is a research opportunity for undergraduates at 3 major universities, University of Illinois, University of Arkansas, and Howard University. And they're offering this 10-week internship, fantastic learning opportunity, exposing you to all sorts of good stuff, research, academic research. And how much does it cost you? They pay you to go there. $5,000 they'll pay you to attend and learn, get exposed to this fantastic opportunity. In addition to that, you receive free housing for those 10 weeks, and usually when you get in the dorms, you have free food, okay? I think that's included in the housing, and they pay your airfare there and back and forth, going around the ticket. And you've got lots of educational opportunities there. Please consider it. The deadline on the email said February 15th, which I was a little suspicious because that's a Saturday. In the brochure it says February the 17th, which is a Monday. So I'm guessing that's correct. Yep. Okay. So if you want to take a look at this, several students in my last class took pictures of it so they can look into it as well. All right. Any questions on anything we've done so far? All right. We're in Chapter 4, Trigonometry. Section 4.4, that's trigonometric functions of any angle. And we had just talked about the sign conventions in the various quadrants and ways you can remember those. And we were just about ready to start on example 2. But it's not in the slide set, so I'm going to have to go back and find, ooh, that's a better place. So, that was good, but I think this is even better. Okay, so let's do example 2. Given that the tangent of some angle theta is equal to minus 5/4, and the cosine of that same angle theta is positive, greater than 0. Find sine of theta and secant of theta. Okay. Now, you tell me what information you got from this, what you can tell me about this angle theta just from this first piece of information. The tangent theta is equal to minus 5/4. As in, where are you, Waldo? Second? Okay, I know you're not in the first quadrant. How can I say you're not in the first quadrant? Everything's positive in the first quadrant. Okay, so you're not in the first quadrant, for sure. Where might you be? Second is a good guess. Or all students take, you can't be in the third quadrant either because tangent is positive in the third quadrant. All are positive in the first quadrant. Sine and reciprocal, cosecant, are positive in the second quadrant. Tangent and its reciprocal, cotangent, are positive in the third quadrant. And cosine, calculus, cosine and its reciprocal, secant, are positive in the fourth quadrant. So, you know you can't be in the first or the third, so you're either in the second or the fourth. Okay. So this piece of information narrows it down to one of those two quadrants, second or fourth. Now, what does this information tell you? Cosine of theta is positive. Where are you, Waldo? Second? Okay. Not this. Okay. It's the same theta. Yeah, you would have to be in the fourth quadrant because this says you're either in second or fourth. This says cosine is positive. The first quadrant is positive, but you see that same theta can't be in two different quadrants. So where else is cosine positive? Fourth quadrant. So that means this told you it's either second or fourth. That tells you it has to be first or fourth, so you have to be in the fourth quadrant. Okay. So you're in the fourth quadrant. Now, you tell me then what, in terms of x, y, and r, what is tangent theta? Yeah. That's what we're dealing with in this. Remember, our trig identities here, definition of trig function at any angle, are given in x, y, and r. What is tangent? Page 288, if you don't have it known already. It's what? Y over x. Okay. Now, you're in the fourth quadrant, and which of these is negative in the fourth quadrant? Yes, the y is negative in the fourth quadrant. Okay. And so Aaron? Yeah, that's what I was going to guess. All right, good deal. Okay, we're example 2 on page 289, chapter 4, trigonometry, section 4.4, trigonometric functions at any angle. We just determined, because we know that tangent theta is equal to y over x, we determined from the two first pieces of information that theta has to be in the fourth quadrant, and in the fourth quadrant, x is positive, y is negative, so this will be a minus 5 over 4. Okay? Now, given that, can you tell me what sine theta is? That's what they asked for. Okay, the sine theta is always y over r. We know what y is, minus 5. But we don't know what r is. How could we get r? R is equal to the square root of x squared plus y squared. And we know what x and y are. This will be the square root of 4 squared plus, I'm going to put the negative 5 squared, but it really doesn't matter because when you square it, it's going to be positive. That would be the square root of what? 16 plus 25, and what's that? 41. Okay, square root of 41. So there's your sine theta right there. Negative 5 over root 41. Now, whereas before they usually went out of their way to get radicals out of the denominator, they're not caring much anymore for that. They leave it just like that. Negative 5 over 41. Okay? So, we found out what sine theta was. How about secant theta? That's r over x. And what is that? Square root of 41. You know what that is. You just calculate it. And what's your x? 4. Done. Boy, that wasn't bad at all, was it? Does everybody see that? How we went about getting it. Okay? Pretty straightforward. Now, unfortunately, this one doesn't have the this on the PowerPoint, so let's just make sure they got it right. They have negative 5 over root 41. They actually worked it out to see what fraction that would be. And just to give you an idea, signs have to be between minus 1 and 1. Is this between minus 1 and 1? 5 is the square root of what? Negative 5 is what 5 is. 5 is the square root of what? 25. So square root of 25 is less than the square root of 41, obviously. So this is a number between minus 1 and 0. So it is a minus. Now secant, remember, is always outside of that. It's either, and this happens to be positive, so that's got to be greater. Well, what's the 4 is the square root of what? 16. Well, 41, root 41 is greater than root 16, so this has to be something greater than 1. So everything seems to fit. So we feel good about it, and they actually did the calculation to see that came out about 1.6. The other one was about negative 0.8 or something around there. All right, that was example 2. They still don't have example 3 on the PowerPoint, so let's clear what we've got here, unless anyone needs this a little longer. Anybody? Everybody got it? Okay. So let's clear this ink and go to example 3. Evaluate the cosine and the tangent functions at the quadrantal angles. Now what that means, the quadrant boundaries, quadrantal angles of 0, pi halves, pi, and 3 halves pi. So we want to do cosine at each of those. Cosine 0, cosine pi halves, cosine pi, whoops, why am I getting so far apart? I don't know, and cosine 3 halves pi. Okay, we also want to know what the tangent is at each of those. Tangent at 0, tangent at pi halves, tangent at pi, and tangent at 3 pi over 2. Okay. Actually, to me, cosine's easier. Let's do that first. What is cosine? And that's supposed to be a 0, not a theta. I don't know how that became the theta. Okay, I've been writing thetas, so just came up. Cosine of 0. What is cosine of 0? Okay, and what's that? Okay, so let's draw our angle here. It doesn't have to, well, here's the angle. It's 0. And we can put that x anywhere we want to. Your x is x, and your r here is also x, because you're at that point. You're going around here. So what is your cosine of 0? If they're equal to each other, five. 5 over 5 is 1. Now, I don't know where you got your 5, but whatever the radius is, that's also your x value when theta is equal to 0, your x is that. So whatever it is, it could have been, I don't know where you got your 5, but wherever it was. They put the unit circle there, 1, 0. That's what I was thinking. If that is 1, the point here is 1, 0, 1 for x and 0 for y. Your radius is also 1, so that would be 1 over 1. Okay? What is the cosine of pi halves? Is what? Okay. Where are you using these numbers? Okay. Okay. If you use those, that's fine too. That was example 1. We're on example 3. Okay. Now I see where you were getting that. But you're not at that point. Okay. You're up here. Okay. And you just figured out that r was 5. Because the square root of 3 squared plus 4 squared. Okay, so that's fine. And here, x was also 5, so 5 over 5 is 0. When you're up here at 90 degrees, you're at the point 0, 5. Down here, you were at 5, 0. Or 1, 0, or whatever value you want it to be. But if you're using this one, that would be at 5, 0. What would the cosine be? Cosine of pi halves. Pi halves is a 90 degree. It would be x over 5, right? X over r, right? Your x is 0. And here's Amari. Okay. We're doing example 3, bottom of page 289. In Chapter 4, Trigonometry, Section 4.4, Trigonometric Functions at any angle. And what we're trying to determine is what the cosine of pi halves is. Cosine of pi halves. Help me, somebody. Is what? 0. Because the x value is 0. How about cosine of pi? Is what? -1. Yeah, -1 over 1, which is -1. Okay? Cosine of 3 halves pi. Zero. Perfect. Okay. Not that perfect. Okay. Now, what is tangent of? That's supposed to be a 0, and it came out of theta. Oh. The old gray cells must be falling apart up here, okay? Cosine of 0. And feel right? Okay. Man, my neck's hurting. I don't know why. What is tangent of 0? 0, exactly. How about tangent of pi halves? Undefined. Now, how can you tell that just looking across the page here? Tangent is sine over cosine. If cosine is 0, can't ever divide by 0. That makes it undefined. Okay, tangent of pi would be 0 again, and tangent of 3 halves pi. Undefined again, because you're dividing by 0 again. So yeah, those are undefined. So that's pretty straightforward. Now, they chose the unit circle again to use. Perfectly fine to do it, even though we were doing any, but why not use the unit circle? Now remember, for each and every one of these examples, there's also a checkpoint. You can do those as soon as you get out of class. I'd find some place to do it before, or after you get out of whatever class follows this. When you have a little bit of free time, go back and try to do your checkpoints for everything that we've done in class. Now we're moving to the concept of reference angles. It'll take me a while to get there. There we go, reference angles. Okay. Now, basically, let me just scroll back. What we were doing before, to me, using these give you the trig functions at any angle. Doesn't matter where you got the quadrant, you know what the signs are, you can get them using x, y, and r. If you don't know r, it's the square root of x squared plus y squared. Okay? So you can get them that way. The other way that we could do it is the reference angle. To me, that way is just as good, though quite often I refer to reference angles. I guess that's why they call them reference angles, because they're good to think in terms of those two. Okay? So the values of the trigonometric functions at angles greater than 90 degrees, but less than 0 degrees, so you could be going negative this way or positive past 90, can be determined from their values at the corresponding acute angles called the reference angle. This is just another way of doing what we're just doing with the x, y, and r. So here's our definition of a reference angle. Let theta be any angle in standard position. Generally not in the first quadrant, but even in the first quadrant it would. So it could be over here, it could be down here, any angle in standard position, meaning your initial is the positive x-axis, and the terminal side is wherever it happens to be. Okay? So, the reference angle for that angle theta would be the acute angle. Always acute, never obtuse. The acute angle theta prime, and that's what this book calls it. Some other texts I've used called it theta sub r or theta superscript r or something like that. This book calls it theta prime. Don't confuse that with taking a derivative that we'll do in calculus. But theta prime is formed by the terminal side of theta and the horizontal axis. So, if you were in the first quadrant, the reference angle is the angle theta. Because the terminal side is here, the horizontal axis is there, your angle theta and your reference angle are the same. If you're over in this quadrant, second quadrant, your angle theta is here, the reference angle is between the acute angle between the terminal side and the horizontal axis. So that would be that. Okay? If you're down here in the third quadrant, the the angle theta is all the way around there, but the reference angle is just the same. Okay? Because between the horizontal axis and the terminal side. If you're in the fourth quadrant, your angle is all the way around there. That's the theta. The reference angle is the angle between the terminal side and the horizontal axis. Okay? So it's always an acute angle between the horizontal axis and the terminal side of that angle theta. Now, theta could be negative, and still it's the same thing. Okay? The reference angle
is always an acute angle between the horizontal axis
and the terminal side of whatever angle you do. Whichever quadrant you're in, the horizontal axis and the ray that's in that quadrant. Okay, the terminal side that's in that, whichever quadrant you're in. Okay? Now, so So that's what we mean by theta prime, your reference angle. Now, acute angles are always positive angles, so don't give me a negative. Acute angles are always positive and always less than 90 degrees. Okay. So the reference angle, this is what I was just saying. If you're over in the second quadrant, here's your angle theta. The reference angle would be the one between the terminal side and the closest horizontal axis. That's an acute angle, that's it. Positive angle there. Now, how do you get that algebraically? Well, think of it this way. Here is this straight line angle here is pi, right? Or 180 degrees, whichever you want to do. 180 degrees or pi, okay? If you subtract the theta from that, that gives you your reference angle, theta pi. So it's either pi minus that theta or 180 degrees minus that theta, depending on what that theta is measured. But in the third quadrant, it's not the same formula, okay? It's the angle theta minus pi, or minus 180 degrees, because it's this angle. So then you flip these two. Now, I don't recommend trying to memorize these things. I say draw it, look at it, and then do the subtraction you need to, okay? It's that angle theta minus pi, or minus 180, that gives you this angle theta. If you're over the fourth quadrant, then the reference angle is here. Tiny little angle there. What do? Here's your angle theta. The theta prime would then be 2 pi, or 360 degrees, minus this angle here. Okay? And that's what we do here. Again, I don't suggest memorizing this. Just look at it and say, oh, what does that angle have to be? Is that theta minus something? Theta, like here, you can say theta plus theta prime must be 180 degrees, right? Or pi. Then subtract and find out what the reference angle is. Here, 180 degrees plus the reference angle is your theta. So then solve it that way. And here, the angle theta plus the reference angle gives you 360 or 2 pi, so solve it for that. Whatever it takes, however you see it best, go for it. And of course, if you're in the first quadrant, the theta and theta prime will be the same. So they're measuring the same thing. Okay. Now, again, I would just as soon use a x, y, r, then your signs all work out. But if you're using reference angle, remember the reference angles are always positive and they're always acute. So here's what we are asked to do. Example 4. Okay? Find the reference angle theta prime when theta is 300 degrees. What I suggest is figure out where you are, Waldo. Okay? 300 degrees. That would be 90 degrees. This is 180 degrees. This is 270 degrees. 300 degrees is 30 degrees past that. Right? 30 plus 270 is 300, right? So what's your reference angle? 60 degrees. Theta prime equals 60. No reason to memorize a formula. Draw your picture, make it make sense, and then figure out what it is. So much easier than trying to remember the formula. Do I do this one first or that one first? Subtract, add, yeah. Figure out where you are and go from there. All right. So I'm going to erase most of this since I got a pretty good coordinate system here. I'm going to keep it, okay? Now, uh-oh, SpaghettiOs. Theta is 2.3. What does that mean? That must be in radians. So now I have to switch gears and think in terms of radians. Now, what radian do you know what it is? What is the one that's our equivalency? Back when you were converting back and forth. What? Okay. Okay, what did you say?
I was asking what you said.
Okay. What I'm saying is, what equivalency do you know between degrees and radians that you can always fall back on? Okay, pi radians is 180 degrees. Well, how much is pi? 3.1416, right? That's pi. So this is less than pi. So it's less than 180 degrees. Okay. Now pi halves would be half of pi, which sounds good to me. I'm hungry, but no. That would be 1 point, goodness, why can't I do this? 1.5 something another, greater than 1.5. Well, this is in between that, so you're somewhere in the second quadrant, right? Because this would be 3.16, that would be 1.57 or 57, that's it, 1.57. You're in between those two, so you have to be in the second quadrant. So what's your theta prime? This is the 2.3, theta equal 2.3. Here, this theta is 3.1416, right? So guess what your reference angle theta prime is? Yeah, subtract the 2.3 from this. So subtract 2.3 from that, and you get 0.8 approximately. Okay, 0.8. They put 0.8416. If you deal anything with significant digits, you know that's ridiculous, because this only has 2 significant digits. You only go to the nearest 10. So how can you get something to the nearest 10,000? You can't. So 0.8 would have been the better answer, but they put 0.8. Okay. This is a math book, not a physics book. Okay, physics you pay a lot more attention to significant digits. There it is. I would say 0.8. They say 0.8416. Okay. All right. Everybody understand that, or have any questions? All right, if there's no questions, let's move to the next one. If I can get things to erase here. Okay. Here we have negative 135 degrees. Well, going negative, that means you start at standard position, positive x-axis, but go clockwise. This would be negative 90 degrees, right? And this would have been negative 180. You're not that far. Negative 135 must be somewhere in there. So this will be theta equal negative 135 degrees. Now, it happens to be, okay, well, we'll figure that out. So, what is your reference angle between the horizontal axis and that terminal line? Terminal side, this is it right here. This is your reference angle, theta sub r. Oh, I'm sorry. That's what other books call it. This book calls it theta prime. Either thing will work, theta prime. Now, how do you get that? Say this again. That will certainly work. 180 minus 135. Just forget about the signs. You know, do what makes sense. And what does that come out? 45 degrees. Always acute, always positive. Okay? 45 degrees. Does that make sense? Now, so what? Okay. Why are we messing with this? And by the way, there is a checkpoint, so please do the checkpoints. All right. Oh, let's see how they did it. Let me erase my scratch. I'm sorry, my stomach's up here just growling away. People at home probably can hear it. I've got one more class before I can eat lunch, so I mean, I don't know how I'm going to make it. You okay? But anyway, let's do the first one. Because the 300 degrees lies in quadrant 4, the angle it makes with the x-axis is, and they go back to their formulas. Fine, if you want to do that, draw the picture and see what it takes. And actually, when we said 30 degrees past that, it made it so simple to do. But however you do it, that is 60 degrees, and that's what we got. That's your theta prime for the first one. For the B one, oh no, they draw the picture here, and it makes perfect sense. If that's 300 degrees around to that, you have 60 degrees left to get the 360. Makes sense. Okay? I would draw the picture first, not use the formula first. Whatever. The B part, the 2.3 lies between pi halves, which is 1.5708, by the way, and pi, which is 3.1416, by the way. It follows that it has to be in the second quadrant, because it's between pi halves and pi. Second quadrant. And its reference angle would be the difference, and again, they're using the formula. To draw it out, I would draw first and calculate second. And they got that. I would draw first and say, you're somewhere in this quadrant at 2.3 radians. This down here is pi radians to subtract the 2.3 from the pi. Okay. I wouldn't do this first. I would do this first and then see. And that comes up to be 0.8416, blah, 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 blah. Okay, the C one, first determine, where are you, Waldo? And they did it this way, which is perfectly fine, but why go to all that much trouble? They first find its coterminal angle by adding that negative angle to 360, you get 225. Then you figure out 225 over in the third quadrant, past 180, and then so you subtract 180 from 225, and you get that. Y'all did it just by drawing the picture, okay? Without doing, I don't think I heard you do that. That was 45 degrees, just what we got. We did it this way. Doing this way, what is your reference angle short of 180? So just subtract that from 180. Rather than going through this, okay? That's fine. You can do it that way. If you see that better and it makes sense to you, go for it. Me, the way you did it, said, this is 135 degrees. How much further you need to get to be 180 is 45 degrees. Okay. You're doing the same thing. Okay. So your reference angle, 45 degrees. Any questions on this? Okay, and by the way, there are checkpoints there for 3 checkpoints for reference angles. All right, so such a weird way to describe this. Trigonometric functions of real numbers. That's what we've been doing from the very beginning, trigonometric functions of real numbers. Okay? It's just sometimes we call them radians, sometimes we call them degrees, but they're all real numbers. Okay? To see how a reference angle is used to evaluate the trigonometric function, consider a point xy on the terminal side of that angle theta. Okay? Which will also be on the side of the reference angle theta prime. Okay? Because you use the same terminal side. Okay? Now, doing the other way, where you just did x, y, and r you get from the square root of, if you know x and y, x squared plus y squared equals r squared at the square root of that, you got r. Always positive, okay? And then just do the functions like we always did, okay? But to use the reference angle, since this is always acute and positive, then the same trig function that you used here, use for this thing, and then determine the SIGN sign. So that's the only difference. You just use the absolute values there. You treat it as an acute angle, everything's going to be positive. And then once you've got the calculation done, you assign a sign to it, a SIGN sign. So see how the reference angle is used to evaluate trigonometric value. Consider the point on the terminal side of that shown here. Determine what the trig function is of the reference angle. That's always going to be positive. And then if it's in the second quadrant like this one is, your sine or your cosecant are going to be positive. All the others will be negative. So just do your calculations based on opposite, adjacent, and hypotenuse, just like we used to do for any acute angle, but then adjust it at the end by the proper plus or minus sign. If I say sine, I don't know if you know, I mean SIN sign or SIGN sign, so the plus or minus sign. Okay. Okay. So by definition, you know that the sine of theta, now this is on our x, y, and r, is y over r, opposite over adjacent, opposite over hypotenuse. Tangent is y over x, opposite over adjacent. For the right triangle with acute angle theta prime and the sides of the absolute value, so you're not counting anything being negative, you have sine of theta prime is opposite over hypotenuse, just like this was, only you're using the absolute value here over the hypotenuse r. The same r is here. Tangent of theta prime, opposite over that. Now it's the absolute value of y over absolute value x. So you see, these are always positive. No matter where you are, these are always positive. So once you calculate them, then say, well, wherever we happen to be, first, second, third, or fourth quadrant, what's the sign in that quadrant? If it's negative, put the negative here. If it's positive, leave it just like that. Same thing with tangent or with any of the other angles. So you just determine where you are and assign that plus or minus sign to it. Okay? Now, 6 of one, half dozen of the others, it's doing the same thing. Okay. So it follows that the sine of theta and the sine of theta prime are always equal in magnitude, except possibly the SIGN sign, the plus or minus sign. The same is true for tangent, same is true for cosecant, same is true for every trig function. In all cases, the quadrant in which theta lies determines the SIGN sign of the function value. So what we do to evaluate the trig function of any angle, find the value of the trig function of any angle, first determine the trig function, that same function value for the theta prime, which is always acute, so that's always going to be positive. And then, depending on which quadrant you're in, either leave it positive if your trig function you're dealing with is positive there, or make it negative if it's not. Affix the appropriate plus or minus sign to the function value. So, I find it just as easy to use x, y, and r with the signs, and it always works, okay? But if you don't know those, or if you just, this way works too, okay? Says you can greatly extend the scope of exact trigonometric values, things that you know exactly. For instance, since you know the function values of 30, means you know the function values for all angles for which 30 is a reference angle. That's where it does come in pretty handy, okay? So they come up with this table. And they do up to, well, they've left off a bunch. 0 degrees, 30 degrees, 45, 60, and 90. Those are our basic. Then they jump to 180 and jump to 270. Those are the quadrantal angles. Those are defined in quadrants. Okay. But you could subtract 30 from 180, you're in the second quadrant. Add 30 to 180, you're in the third quadrant. And subtract 30 from 360, and you're in the fourth quadrant. And these will still be the same values, except for the these will be the same value except for the sign. The sign will always be positive in the second quadrant, the cosine in the fourth quadrant, and the tangent in the third quadrant. So, with these angles. So, to me, this table doesn't say a lot. I mean, these are things we already knew, but they repeated them. These are things we already knew, but they repeated them. Doesn't really. All right, does that make sense? These are the common angles, and then use those as your reference angles, and you can add or subtract from 180 or 360, and you get the same values. Plus or minus the sign. Okay. Now, there is a little blurb over in the left-hand side of page 291 in the margin there. And it's the same thing I think I told y'all earlier. If you're doing the sign of your angles, 0, 30, 45, 90, 60, and 90, just think of the square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. You got it. And it's that the left margin on page 291. It's, to me, helpful to remember. I know them, I've used them so much, I know them, but it's helpful for me to tell how to help other people figure them out. Okay. So I think we're ready for example 5. Now, example 5, you can also see larsonprecalculus.com for an interactive version of this type of an example. So if what we're doing now doesn't satisfy you, go back and do that when you're doing your checkpoints, because you'll be at larsonprecalculus.com then too. All right, so let's evaluate each trigonometric function. Cosine of 4/3 pi. Where are you? You're what?
A little past 180.
Absolutely, or pi if you want to do that. In fact, it's 1/3 of a pi past pi, right? So pi would be 3/3 pi, and this is 1 pi thirds past that. So the reference angle will be pi thirds, right? What's the cosine of pi thirds? Oh, which quadrant are you in then? The third quadrant, okay. And sine, a cosine is what SIG in sine in the third quadrant. Cosine is, all students take chemistry. Positive over here in fourth, negative. Okay? So, or calculus or whatever you want to take. Okay? With starts with C. So you're in that quadrant, so it's going to be the minus the cosine of pi thirds. That's it. What is cosine of pi thirds? 1/2. So that will be minus 1/2. So this will be, because you're in the third quadrant, minus the cosine of pi thirds. Because pi thirds is the reference angle for that, because you're 1/3 past the 180, or pi, and so this is going to be minus 1/2. Okay. Tangent of negative 210 degrees. Where are you, Waldo? You're in third quadrant again, because, no, you aren't, are you? Yeah, these are minus. So that's minus 90, minus 180. You're how far past that? 30 degrees further than that, minus 210. Hey, 30 degrees past 180 or pi, pi. That tells you your reference angle right there. Okay? So the reference angle is 30. Everybody agree? Okay. So, and if you're in the second quadrant, which is where you are, right? What is tangent in the second quadrant? Well, it says SIG in sine, plus or minus sine. Negative. So it'd be negative tangent of 30 degrees. And what is tangent of 30 degrees. Second? Square root of 3 over 3? With the negative sign? Okay. Okay. It's y over x, and the y would be 1/2, and the x would be root 3 over 2. So yeah, it's 1 over root 3, which is root 3 over 3, but negative. Okay, cosecant of 11/4 pi. Okay, where in the world are we, Waldo? So you can start doing it this way if you want to. 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi, 6/4 pi, 7/4 pi, 8/4 pi. Trying to get tired of this. 9/4 pi, 10/4 pi, 11/4 pi. Where are we? Second quadrant. Cosecant is what in the second quadrant? Plus or minus?
Okay.
Positive, because it's the reciprocal of sine. The sine is positive there. So it's going to be positive. And what these were all quarter pies. I was counting this way, but that's also a quarter pi from 1/8. So this is going to be the cosecant of the positive cosecant of pi fourths, which is 1 over the sine of pi fourths. And what is the sine of pi fourths? Square root of 2 over 2. Or another way to say that is 1 over root 2, right? And since you're inverting it, then this would be just root 2. Positive. Okay? A positive is right. Root 2. Does that make sense? Okay? Figure out where you are. However you want to do that. However you want to do this. Another way you could have done was subtract 2 pi from this. 2 pi would have been 8/4 pi. That would have been 3/4 pi. 3/4 pi is over the second quadrant. However you wanted to do that is perfectly fine. Once you determine where you are, determine the sign of that function there. This is the reciprocal of sine, and sine is positive in the second quadrant. So you know it's SIG in sine, it's plus minus sine, it's going to be plus. Okay? Then determine your reference angle, and that would be pi fourths, because you're 1/4 shy of pi, so your reference angle is pi fourths. The cosecant is 1 of the sine. However you do this, if you know this, go and write it down. If you don't know it, I know that one, and it's a lot easier for me. Okay, does that make sense? So there was example 5. Let's see how they did it. Okay, they started off because theta equal 4/3 pi lies in quadrant 3. Okay, the reference angle, and if you just draw the picture first, don't mess with formulas. Draw the picture first. Picture first. There would be 1/3 pi, 2/3 pi, 3/3 pi is pi. This is 1/3 pi past that. 4/3 pi is 1/3 past pi. Okay, so that's your reference angle. You didn't need to do any formula and stuff. You know it's pi thirds past pi. Okay, you know that. Okay, because you're dealing with, they didn't write it down here, I think it was cosine, wasn't it? In the third quadrant, cosine is negative. But then it would be the negative of the cosine of pi thirds. Pi thirds is the adjacent over hypotenuse. That's exactly 1/2. So it's negative 1/2. So it's minus the cosine of pi thirds. Cosine of pi thirds is 1/2, so it's minus 1/2. Does that make sense? I like using reference angles, but if you have them and already have the X, Y's, and R's, just plug them in, plug them in. I mean, that to me is easier than this. But there's sometimes you may not have those, and then you look at the pictures and see what you got. Okay. The B part here, and again, they went back to the coterminal angle. You know, in my mind, it's just as easy to go minus 90 degrees, minus 180 degrees, and to get to 210, you go 30 degrees past 180, and that gives you a reference angle right there, 30 degrees again. They went around their elbow to get to the nose, you know, so they added 360 to get 150. Now you subtract it. Yeah! Why take so many steps that are unnecessary, okay? Coterminal 150, then you have to figure out from 180, you're 30 degrees short. So you're in the second quadrant, 30 degrees is your reference angle, okay? And by the time you did all this, I forgot what trig function we were doing. Was it tangent, I think? Okay, so the tangent of negative 210, because you're in the second quadrant, tangent is negative there, that'd be the negative the tangent of 30, and you knew that the tangent of 30 was root 3 over 3, so that's negative root 3 over 3. Good for you. And then the C one. And this is, to me, a little bit easier than what we did, but I was just showing you. You could do that. Doesn't my knees hurt? 11/4 pi. If you subtract 2 pi from that, where I said you could, 2 pi would be 8/4 pi. That leaves you 3/4 pi. Where are you with 3/4 pi? You're in the second quadrant. 1/4 pi, 2/4 pi, 3/4 pi. Okay? So it's coterminal with that. But I wouldn't even mess with that. I mean, just subtract it. Yeah, you know it's that. Okay? And then, because you're doing cosecant, that's 1 over sine. Well, sine is positive in the second quadrant. So you know it's going to be the positive cosecant of that. Well, the reference angle, though, is pi fourths. So it's the positive cosecant of pi fourths, which is 1 over sine of pi fourths, which is root 2. Because sine of pi fourths is 1 over root 2, or root 2 over 2, 1 over root 2. Reciprocate that, you get root 2. Okay. Whoa! That's the last slide in the PowerPoint, but we still got 2 more examples to go. Any questions on this before we leave it? Okay, so let's do example 6. Let theta be an angle in quadrant 2 such that the sine of theta, so theta is an element of quadrant 2, okay? Such that sine theta is equal to 1 over 3, okay? Do those 2 pieces of information make sense? Do those jive together? If theta's in quadrant 2, what's the sign of trig functions in quadrant 2? What? Plus or minus sign?
Sine?
Yeah. Positive. So yeah, this makes sense. This says it's in quadrant 2, this says that the sign is positive. Those make sense. Those jive. Okay? Now, this is not one of our favorite functions, angles. Okay? We didn't have anything whose sine is 1/3. 1/2, yes. 1/3, no. Root 3 over 2, yes. 1/3, no. So if you're in the second quadrant, what is sine? What in whatever quadrant, what is the sine function? Sine of theta is, go back to your x, y, and r. What is that? X, y, and r. What is sine theta? Y over r. Okay? Well, guess what? It's positive, so y is 1 and r is 3. Okay, y is 1, r is 3. So now you're on a 3 circle, not a unit circle, but a 3 circle. Okay? I like to go on and draw it. Okay? Now, what I usually find is easier for me to draw the circle first, then put in the axes, and then do 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, not very even circle, but you get the idea. You're over here in the second quadrant, and your y is 1, and your radius is 3. Okay, there you are right there. There is your angle theta. Theta is in quadrant 2, and the sine of it is 1 over 3. Okay, opposite side is 1, adjacent hypotenuse is 3, because it's a 3 circle. Okay. Now, they probably don't want you doing it this way. To me, that's the easiest way to do it. Okay. All I got was what was given here. Find A is cosine of theta. How will you do that? So what we know here, this is 3, this is 1. How would you get cosine theta? What is cosine theta, by the way? It's x over r. Now you know in the second quadrant x is a plus or minus number. Say again? Negative number, right? X is negative over there, right? Okay. Do you know the value for x? How do you get that? No. Okay. No, that's your radius. So this is 3. It's what? Yeah. And we know this is a negative something. I know. 3 is your radius. It can't be your x2. Not there. You see, you're short of 3. Right? How do we get it? Does the name Pythagoras ring a bell? Oh, yeah, we'll do that. How does that go? Okay, x squared is equal to r squared minus y squared, right? Because x squared plus y squared is r squared, right? And r squared is 3 squared minus 1 squared. And this is 9 minus 1. 8. So x squared is equal to 8. So x is equal to, it's plus or minus the square root of 8. But we're going to use the minus because we're over here in the second quadrant. So it's going to be minus the square root of 8, which you could write as minus 2 root 2. Agreed or not? So 8 is 4 times 2. Square root of 4 is 2. Square root of 2 is square root of 2. So this is what your x is. Okay? And you choose the negative because you're over here in the second quadrant. Now this isn't how they're wanting you to do the problem, but this is, to me, makes sense. That the cosine would be minus 2 root 2 over 3. There it is. If I could write. Okay. Does that make sense? Now, how they wanted you to do it is perfectly fine. They said sine squared plus cosine squared is equal to 1. That's 1/9. Right? Sine squared would be 1/9 plus cosine squared is equal to 1. So subtract 1/9 from 9/9, and you get 8/9. I forgot my 3 here, didn't I? No. I wrote it somewhere. There it is, yeah. 8/9 minus 8/9 is minus 2 root 2. The square root of 8/9 would be square root of 8 over square root of 9. You use the negative of that. So either way you want to do it is fine. You're really doing the same math. And actually the sine squared plus cosine squared equal 1, that gives it to you pretty quickly too. So you got several ways to get there. Use the way that makes the most sense to you, that you see and understand. So, oh yeah, I got that one. Okay. Don't try to follow anyone else's specific pattern. Okay, that was 6a, and that's what they got, negative root 2 over 2, negative 2 root 2 over 3. Okay. So, the B part said, find the tangent of that same angle theta. I was starting to erase it. I'm glad I didn't. The tangent of that angle theta, same angle theta, what is tangent? Y over x. Now we already knew the y from our original. That would be 1. And your x was negative 2 root 2. Okay? So, if you want to rationalize that denominator, this is going to be a minus, and the second quadrant tangent is negative, so this is making sense. Negative root 2 over 4. Okay? You multiply the denominator by root 2 and numerator by root 2. This will be root 2. This will be 2 times root 2 times root 2 is 2. 2 times 2 is 4. So minus root 2 is 4. Now, yeah, they did sine over cosine, which is okay too. Why not you? If you got the x and y, use it. Okay, it just is so easy. Negative root 2 over 2. Root 2 over 4. And there's a checkpoint there too. Now, the question comes, how much of this do you have to keep in mind when you're using your calculator? Anyone need this any longer? Is that in your way? Everybody got it? Okay. Guess what? Your calculator is going to take care of just about everything you need. Okay? So, use a calculator to evaluate each trig function. Cotangent of 410 degrees. How many of your calculators will do that? I bet you none. Unless you have a really fancy one. You might be able to do it on a really fancy one. What would be the first thing I would do? How do you know that? One over tangent of 410 degrees. Right? Cotangent is 1 over tangent. Your calculator will do that one, right? So 1 divided by tangent. Oh, make sure you're in what? Degree mode before you ever start this, okay? Make sure you're in degree mode. Then do 1 divided by tangent of 410 degrees. Or, the book likes to do tangent of 410 degrees, put that in parentheses, and then do an invert 1 over x key, or x to the minus 1 key, whatever your calculator has. Just as easy to do 1 divided by tangent of 410, if you're in degree mode. What do you get when you do that? What is that approximately?
0.83.
Yeah, 0.839. Now, with cotangents, it's hard to tell because they can be any value from negative infinity to positive infinity. That certainly is in that range, so we're okay with that. Now let's do sine of negative 7. How do you do that?
First, that makes
Yes, good catch there. That's not -7 degrees. If you don't see the degree sign, they're talking about radians. So make sure you go back to radian mode. Now all you have to do is punch it in. Sine, once you're in radian mode, sine, and when it opens up, now in this case, use the little minus sign that's in parentheses, not the subtraction key sign, the one that's in parentheses, and do -7. Close parentheses, equal, you should have it. You don't have to do reference angles or anything else. Your calculator will take care of that. What do you get? Okay, 6.5 whatever. 657 I would have said. Okay, now, does that make sense? Sines and cosines are always between -1 and 1. So at least it's in the right range. Now, if you wanted to check to see if it makes sense otherwise, we could do this with this one too. 410 degrees. There's 90, 180, 270, 360. 360 and 90 would be 450, right? So this is in the first quadrant. It better be positive. It was. Okay? So that's all we can do there. -7 radians. There's pi radians is 3.14. 2 pi radians would be 6.28. So, well, I'm going negative. That would be -3.14, -6.58, just a little past that, just a tiny amount past that. But you're in the fourth quadrant, sine is negative in the fourth quadrant, so that's making sense. And you're within -1 and 1, so but -1 and 0, in fact. So that makes sense, okay? How about this one? The secant of pi ninths. What mode did you better be in? Gradient mode. You're already in it, so you're fine. Sorry. Okay. Well, I don't have a secant key on my calculator, so what would we do? Say again? 1 over cosine of pi ninths. Now, where in the world is pi ninths? Pi is 3.14. So this is something a little bit greater than 1/3 radian. Hey, you're in first quadrant. Can't help but be in first quadrant. You're between 0 and pi half. Pi ninths is definitely between those two. So you're in first quadrant. It's going to be a positive answer, and it's going to be a number greater than 1, because cosine is always between 0 and 1. 1 over that would be something greater than 1, and it's going to be positive. So what do you get? 1.064. Yeah, they do a bunch more digits, so that's fine, perfectly fine. And there's a checkpoint after that one as well. Please do your checkpoints as soon as you can after class. Let's do vocabulary. How much time we got? 20? Huh? 1 minute? Okay, let's get our vocabulary done real quickly. In these exercises, let theta be an angle in standard position, xy point on the terminal side of theta. R is square root of x squared plus y squared. What is sine theta in terms of x, y, and r? Y over r. What is r over y?
R over y, cosecant.
Cosecant. What is tangent?
Tangent, y over x.
Y over x. What's secant?
Secant, r over x.
R over x. Excellent. And x over r is?
X over r is cosine.
Cosine. And x over y is?
Cotangent.
Cotangent. You're right. Number 7. Because r is equal to the square root of x squared plus y squared, cannot be blank.
0.
Can't be 0, and it can't be negative, but 0 is what they're looking for. The sine and cosine functions are blank for any real value of theta. That could be defined or it could be continuous. Either one of those would be fine. Number 8, the acute angle formed by the terminal side of an angle theta in standard position and the horizontal axis is the blank angle of theta and is noted by theta prime. Reference angle. Good. Homework exercises here would be any of the odds 9 through 11, either 9 or 11, both at Calc Chat, 11's at Calc View. Any of the odds 13 through 17, they're all at Calc Chat. 19 and 21 are at Calc Chat. 23 through 31 are at Calc Chat. 25 is at Calc View. 33 or 35 are at Calc Chat. 33 is at Calc View. Any of the odds 37 to 45 are at Calc Chat. 39 is at Calc View. 47 to 53 Calc Chat. 51 is at Calc View. 55 to 67 all at Calc Chat. 55 is at Calc View. 69 through 73 are all at Calc Chat. 73 is at Calc View. 75 to 89 are all at Calc Chat. 81 is at Calc View. 91 to 95 are all at Calc Chat. 91 is at Calc View. And 97 through 101 are all at Calc Chat. There's true false 103 should be at Calc Chat. There's a writing at 105, and that should be at Calc Chat. Next time we'll start on 4.5, but because y'all were such a wonderful class today, I'll give you a gift, and this will be the first test. Because the first test just covers 4.1 to 4.5. 4.1 to 4.4, which we just finished. So, now, don't even guess that you might be able to do all your work. Maybe you can, but my guess is you're going to need some scratch paper. Okay, so these are packed in here, so I would definitely use scratch paper, and I would suggest that you turn in the scratch paper with the work. That way, if I find you made a transcription error, I can give you more partial credit if I see you scratch paper. I'll put it that way. Sometimes I can give you full credit if I see you just copied something wrong. Now, number 6, you'll notice there was ridiculous problem. Okay? Find the exact values of 6 trigonometric functions of the real number t at the point in standard position 17/13, 8/13. That's supposed to be a point on the unit circle. 17/13 is greater than 1. This was how it was in the test bank. I thought I made a typo. No, they made a typo. So I changed the whole problem to be 15/17, 8/17. That's the XY value of that. So you base your answers on that. That's number 6. The rest of them I think are good. It's a lot there. Shoot to finish it within a week, but if you need more time, you can have more time. Just be sure you get it in before I give you the next test, which will be at the end of 4.8. So take the time you need, but try to get it, for sure, get it in before we finish the chapter. Okay. Any questions? And if you do run into questions while you're doing it, ask me next time, and as many times as you can. All right, good deal. Let me